Welcome back to Channel 9 Live at TechEd North America. I'm Simon Perryman, and I'm joined by Eldon Christensen, and we're going to be talking about some of the clustering enhancements coming in Windows Server 2012 R2. Now, last day of the conference, so we've gone through a lot of information already. I mean, Eldon, why don't you introduce yourself and actually just give us an overview of some of the cluster sessions you've done this week.
Sure, so my name is Eldon Christensen, and I'm a program manager in the Windows Server organization, and I own the failover clustering feature that you see in Windows Server. We did a session, I did a session on Tuesday where we talked about cluster networking, and so that was really kind of a in-depth session. Did a session earlier today where we covered all the new storage features in 2012 R2 all up, so we talked about block storage, file storage, availability enhancements across all of those. And you're doing the session later today, right?
I have a session almost directly after this on managing and deploying clusters as well. And not to mention that, the rest of the team has some other sessions, right? A lot of cluster sessions this week at TechEd.
Yeah, there's, we're doing sessions on application availability strategies, which is around using shared VHDX. It's around doing guest clustering, doing VM monitoring.
There's an upgrade session,
right? There's an upgrade session. There's a session on how to actually upgrade your private clouds from 2012 to 2012 R2. So they'll tell you how to get your Hyper-V clusters upgraded to the new 2012 R2. Exciting features coming.
Very nice. So a lot of sessions. If you just check the recordings on Channel 9, you'll be able to see all of these. But now, Eldon, what's kind of the big goals that we made with clustering in this release?
So just kind of all up, I mean, from a bigger perspective, what we really wanted to do with 2012 is we knew, okay, so if you go back to 2012, that was a 3-year release, big features, a lot of stuff. With this release, it was a shorter release cycle, 1-year release cycle, and so we could only fit in so many features we knew, and we didn't. And opposed to spreading ourselves really thin and just trying to do a little bit of improvements across a whole lot of things, what we really want to focus on was let's narrow down on a couple very specific scenarios. Let's nail those scenarios and deliver more end-to-end functionality across those. And so our scenarios were really around hosted cloud, private cloud, and cloud service providers. So we were really trying to focus in on those scenarios and how we could deliver on them.
So what was kind of like the big features then for, say, hosters?
So if you look at clustering, with clustering, when we focused in on hosters, for example, okay, so let's take a step back. So achieving higher levels of availability for your application. So one of the first things, one of my big recommendations, availability, is if you want to get higher levels of availability, the first thing to do, virtualize. If you throw your app into a VM and you make that VM highly available, you are naturally just made your application more available with no changes. You just didn't do anything. You could take and just throw it in a VM and you've made it highly available.
I mean, it immediately adds that mobility to it.
Right. So then you've clustered the virtual machines so that if a host failure, the VM will fail over to another node. You've got all the mobility features. You're going to do some maintenance, or you can put a new network card in a server. You just live migrate the VM, 0 downtime. You've increased your availability. Now, for some tier 1 deployments, they actually want more. They want higher levels of availability. And that's when we start to think, like SQL, for example. People with SQL want to get higher level availability than even what is available from just making it clustered. So what you can do there is what we call a guest cluster, where you're running the clustering within the virtual machine, and then you've actually fail over the application. So you actually got not just VM mobility, but actually think about...
That's host clustering, the VMs move around.
Yeah, so that's host clustering, and then there's guest clustering, where you actually have app mobility, where you're failing over the applications from one VM to another one. So our story in there, so let's time warp back to Windows 2008 R2. Our story there was to use iSCSI, right? You had to take iSCSI, present it up to the virtual machines, and
that was for the shared storage for that guest cluster.
Right.
Okay.
For the shared storage for where you'd put your database files to fail over when SQL failed over across. But some customers were like, I don't have iSCSI. What am I supposed to do? So then in 2012, we did a little better, and we introduced virtual fiber channel. And so with virtual fiber channel, then you could actually take a fiber channel LUN and present it up to the virtual machine, and then you could fail that over. So that was a little better.
Yep.
But then there were customers saying like, well, I'm using SaaS, or what am I supposed to use? And then especially, the most important scenario was hosters. And hosters were telling us, saying, hey, I need abstraction between my tenants, VMs, and my host layer. So I don't want to present my storage to the tenant VMs. I want to have a layer abstraction. And so that's where the shared VHDX really comes in, is that you basically just create a VHDX file, present it to those virtual machines, and that appears as shared storage.
Right. So can we? So what? I mean, what's the big benefit, right? Why do hosters want to use the shared VHDX?
So yeah, they don't want to present that LUN up. They want to have that layer of abstraction. So and then
is that so that the tenants can't see the underlying storage infrastructure?
Yeah, they want to be able to have big LUNs underneath with multiple tenants on top of it, multiple VMs, and then they want to create VHDXs, and those are really an entity. So you basically have 3 VHDXs. So if you're going to do a shared SQL deployment, you're going to have one VHDX for the host operating system for virtual machine 1. You'll have another VHDX for the host operating system for virtual machine 2, and then a third VHDX which will be shared, which you'll put your databases on so that both VMs can access that data.
Can we actually take a look at this?
Let's see it. All right, here we go. Okay, so if you look at my...
Now, as you switch over, I also want to remind our audience, please feel free to ask questions. We will take these live as well. Just type them in the chat queue at the bottom of the window.
Okay, love questions, so please ask questions. So here you can see I have got a 2012 cluster which is up and running. I have got 2 nodes here, so you'll see I've got Failover Cluster Manager open. I've got 2 roles, 2 VMs, so node 1 and node 2. So I can just, if I go into... so the first thing we want to do is let's add a virtual hard disk. So I can say new hard disk, and we'll create this hard disk.
And so this kind of looks like the Hyper-V Manager UI. Are we pulling that up into Failover Cluster Manager here?
You're exactly right. So we want to give a totally consistent experience. So what you're actually seeing is we're actually calling into the Hyper-V Manager UI from clustering. So it's like a shortcut. Think of it like a shortcut that we're just trying to pull it all together so you don't have to jump between the UIs
between the different ones. Okay.
So here I'll just create a dynamic VHDX. I'll call it shared. I don't know. I'll call shared 5. I'm just going to make this up here. We're going to stick this out. So one of the important things is that you need to put the VHDX file either on like a CSV volume so that if those VMs move around, they can all access it, or you need to put it out on an SMB share. So it can be on a remote scale-out file server as well. So we're going to go to our C drive. We're going to go to cluster storage, and here's my volume. Let's go volume 1. So we select our folder. There's my new shared VHDX. We're just going to make this small.
So as you're doing this, are you initially configuring it to be shared across all these nodes when you first create it, or is that something that you do later?
So I'm just creating a normal VHDX the way I normally would, so nothing special about it. All right, so it's not creating this. Let me try in a different volume. So my volume is full here. So let's go on volume 2.
All right, there we go.
There we go. So I created my shared VHDX on volume 2. So now once I've created it, so now I can go into my virtual machine. So here's my virtual machine, and I go settings. And again, you're seeing the same wizard we launch from Hyper-V. So the same thing you used to.
Yeah, that's just normal settings, right?
Yep,
Nothing
normal
different.
settings. So then I can go into here's my SCSI controller, and I can say I want to add a hard drive. So now I can browse to where I created that. Let's see if I remember, since I chose a random path while we were going here. I think I created on volume 2, and there it is, shared 5. So here's my VHDX. And then what I do is, then I need to go to the advanced features, and here's the new stuff. So here is the new checkbox. So what you need to do is you need to go and just check this box to say enable shared hard drive, and you say OK. And there you go. And so now it's shared. And then you do that on each node in the cluster. So if you had 5 nodes, you would need to go and attach it to each node and connect it to each one. You can do it through PowerShell as well. That's kind of the way I would recommend it if you were to create
scriptable.
Yeah.
Easy,
so, and there's a new dash shared disk parameter you have to use. So when you do the add virtual disk commandlet, you just use the new dash shared disk parameter. And then once you've done that, you can actually just go into the virtual machine. And let me do this.
Now, what are we going to see from within the VM here? So this is within the guest cluster, right?
Yep. So I just flipped into the VM. So here's the brand new 2 gigabyte disk that I just created, And so then you just do your normal things, right? You'll online it, you'll initialize it, and then you'll just go into Failover Cluster Manager. So I'm just going to initialize this quick.
Now, while this is starting, let's just quickly review the storage options that we have both for host clusters and for guest clusters, because there's quite a lot of flexibility now, right? Mm-hmm. So what can you use for the host cluster for different storage options?
So from a host perspective, any block-based storage. So, and what I mean by that, that could be serial attached SCSI, so SAS. You can take a SAS JBOD and use spaces, or you can take a SAS RBOD and connect it up to multiple servers. You can do FCOE, so fiber channel over Ethernet. You can do iSCSI, or you can do fiber channel. So those from a block-based perspective. So if you want to do block storage, you like block storage, those are the options to go. On the flip side, we also now support file-based storage. And so with file-based storage, you're actually going to then create a scale-out file server and run your applications over SMB. All right. So it just created my two gig disk, and then I can just go into Cluster Manager, and then I can add that disk to it. And then you just present it to all the nodes in the cluster. So if I had 10 nodes, I would need to just run that add virtual disk commandlet against those 10 nodes.
Right. I mean, I think this is a great feature. A lot of customers are going to be using this. I mean, it just really simplifies this deployment topology, not having to, refigure out all your LUN management, SAN management, and how you isolate those for the physical servers and then for all your tenants and guests. Yeah,
and I think this is going to be the recommended way we're going to be. This is our recommendation for all customers moving forward, the way to do guest clusters, because we've just had, it can be very presenting a fiber channel LUN up to a virtual machine. Let's be honest, and you got to have a MPIV support, and it's complex to configure, and that leads to being error prone and supportability issues and challenges, and just in setting it up and maintaining it and troubleshooting it. So this is just a very, very simple way to go.
Nice. So what are the other enhancements in the GUI here? I mean, actually, let me even take a step back. I saw when you were configuring the VHDX, under that advanced setting, there was another interesting option there called storage quality of service. Can you briefly touch on what that is?
Sure. So, one of the new, on the VHDX side, so there's kind of a couple really cool features around Hyper-V and storage. One is the fact that you can now dynamically grow the size of a VHDX file while the VM is up and running. So it used to be that if you want to grow the size of a VHDX file, you had to shut down the VM. So that equated to downtime. But now you can dynamically grow the VHDX or shrink it while the VM is up and running. The second thing you can do is that there's new Hyper-V clause policies where you can actually set a maximum value that you want of IOPS that a VM is allowed to take. So if the VM, you don't want to take more than an X number of IOPS, so let's say you're a hoster. So you're a hoster, you've got 100 VMs from different companies that are tenants that are running on your hosted cloud infrastructure. You've got one tenant which is just going crazy in his virtual machine, which is hammering the storage array, which is then impacting the other VMs. You can actually throttle that and control them from getting too many IOPS.
Now this was similar to what we had with the network quality of service, right? Is to avoid this kind of noisy neighbor scenario where you have that one VM consuming all the resources and hurting everyone else on that host.
Yep. It's just taking the concepts that we introduced in 2012. We introduced networking quads in 2012, and now bringing some of these to storage. Absolutely.
Great. Now, I see some other improvements in the UI here. I see a lot more, I guess, information about, what we can do with different disks, different servers. Can you kind of give us an overview of those UI changes here?
Sure. So let's just go look at some of these different things. So one of the pieces of feedback that we've had from customers is if we just, so I've got Failover Cluster Manager open here, is trying to figure out which disk is which. So if you go and click on a disk, you're going to go see, we try to kind of give the same experience that you see in like Windows Explorer. So you're going to see the same, so we use the same icons, and you can get a representation of the free space, and you'll see the file system, and we'll present the drive label here. Another thing that you'll notice is new is that we also present the disk number. So you can see that this is actually disk number 6 on the node which currently owns it. So this is owned by node 1, and you can see its disk number on node 1. So if I were to open disk management, I could go, oh, okay, so now I've got the drive letter, I've got the volume label, I've got the disk number. It's much easier to kind of put these together and which disk is which.
Nice. And I even see owner node as well.
Yep, and you can see the owner node. So here you can see the owner node. Here's node 1.
Now, we have a question that came in from iHeart PowerShell. Should I use storage spaces with my SAN-based LUN within a cluster? What's our storage spaces story?
Sure. Okay, so let's talk about spaces and when do you use it. So spaces is designed to be a SAN alternative. So it's designed to be so that you can take low-cost commodity storage, just a bunch of disks, and that you can use spaces as software to achieve resiliency for those drives. So if you think about what is a SAN, right? If a SAN is basically a bunch of disks with a controller on the front of it. And what is the controller? It's a PC running some software. And then they wrap it in a single sheet of metal and they charge you a premium for it. So what we're doing is we're moving some of that software into Windows. So that'll allow you to go buy low-cost commodity JBOD storage and then use the software in Windows, which is the software you'd normally use out of the controller in the storage array, and then make that a highly available, resilient system. And we provide all the enterprise level features that you would expect out of an enterprise class storage array. You see things like we have parity spaces and mirrored spaces, kind of analogous, just to use words you're familiar with. We use, are similar to, I don't want to say the same as, but similar to RAID 10, RAID 6, RAID 5, RAID 0, RAID 1. We have all of that. You also expect features like tiering, right? We have that you can actually create now spaces that consist of SSDs on the front end, spinning HDDs on the back end hard drives, and then we will intelligently heat map and move data on a block level sub file between the HDDs and the SSDs. So that way, when you're doing reads of data, we will access it from the SSD layer and give you very fast read performance. And from a write perspective, we can use the SSDs as a write-back cache, where when you go to do a write from your virtual machine, it will go down, hit the the SSD layer, get a fast acknowledgement backup on your write, so you get very fast performance. Then we will later on lazy write that data down to the HDD layer, so you can get very fast write performance and read performance.
Very nice.
But it's not designed. So our intention is you don't want to put a storage controller on top of a storage controller, right? So you don't want to go and take spaces, which has software which is designed to be analogous to kind of like a controller in your storage array, and then go put that on top of software which is a controller in your storage array. That's not the direction we're going. So spaces is not designed to be a feature to layer on top of your SAN.
And can we support dedupe and everything?
Sure, absolutely. We have features, deduplication. One of the new features in 2012 R2 is that we can now dedupe live VHDs. Somebody couldn't do before. So dedupe was really focused at kind of VM libraries, at offline VMs that weren't running. Now it can run on live VHDs. And another key enhancement is that it now supports CSV volumes. So you can be running live dedupe on your CSV volumes.
Nice. Now back to the UI. One of the things that I noticed that had changed here in the UI is we now show more quorum information. Could you talk about what's kind of changed in quorum with this release?
Sure. So let's talk about that.
Well, maybe first, let's quickly define quorum.
Okay, so I'll take the total step back. So actually, we'll go for a trip down memory lane. How about that?
Sounds good.
All right, so 2012 R2, let's go 2008 R2. 2008, not 2012, 2008 R2. We're going way back in our minds. So quorum was the definition of in a cluster, we needed a majority of nodes in the cluster to be up and running for the cluster to be functional. So for example, with 2008 R2, if you had a 16-node cluster, you needed to have at least more than 50% of the nodes in the cluster up and running. So if you had a 16-node cluster, that means you had to have at least 9 nodes up and running. If the 8th node shut down, now you no longer had a majority of nodes in the cluster running, and we'd shut the whole cluster down.
So just to clarify, it's not 50%, it has to be greater than 50%.
Greater than 50%. Okay. And so we needed a majority of nodes to make sure that we didn't ever have a split of the cluster.
So would you ever have, say, an even number of voters, like 16 votes in the cluster? Because then you could have this 8 and 8 and you would win, right?
Right. And so that actually kind of leads into the enhancement we made in 2012 is something we call dynamic quorum. And so what dynamic quorum does is that if you have a 16-node cluster, so when in 2012, one of the other features we introduced was a 64-node cluster. And so we're thinking about that, and we said, hey, if you get a 64-node cluster and 32 nodes go down, your whole cluster shuts down.
32 nodes seems like a lot, right?
Yeah, but if you still have 32 good nodes, why do you want to shut down the other? You know what I mean?
Yep.
You still have 32 nodes. You could still be
hosting
hosting
a lot of hardware. That's a lot
hundreds
of hardware
or thousands of virtual machines, and you're going to shut them all down, right? So that seems silly. So we thought about, we need to do better. And so the change is that now when you have, so let's take the 16 nodes example, because that's simple. So in the old world, if you lost 8 nodes, the whole cluster would shut down. And quorum was determined by the total number of nodes in cluster membership.
Every node had a vote.
Every node had a vote. So every node had a vote, and You had to have a majority of those votes to be up and running. So what we changed in 2012, we introduced something called dynamic quorum. Dynamic quorum is now we calculate, instead of by total number of nodes in the cluster, by total nodes and membership, and active membership. So if you have a 16-node cluster, and you power, so now you have 16 votes. You need a majority of 16. You power down a node, now you need 17. You power down another node, now you need 16. Now a node crashes, now you need 15. Now 2 more nodes crash, now you need 13. So we can actually survive an up to simultaneous failure of up to 50% of the nodes in the cluster. So if you had a 16-node cluster, you could lose 7 nodes simultaneously, and the cluster would stay up and running. So now let's take that to R2. So with R2, we took that evolution to the next level, and we took it from not only just being the nodes that were toggling votes, that we're actually changing it to the witness as well. And it really goes back to...
Sorry, what is the witness?
So, okay, so today, a witness is an external entity which helps to be a decision maker when nodes can't talk to each other. So if I have 8 nodes and 8 nodes, or let's just simple, 2 nodes. There's some sort of network communication failure between the 2 of these, and they can't talk to each other. They need some third entity that can be a tiebreaker to decide who should stay up and who should shut down.
Tiebreaker arbitrator, okay.
Tiebreaker arbitrator between the nodes in the cluster. So today we have all this kind of very complex, big long white paper. It's written by this crazy guy, Simon, and which talks about all this guidance about node majority and node and disk majority, node and file share majority. And we have these big long white papers that are very complex about how to configure quorum with a cluster. And people invest a lot of effort.
A lot of consideration.
A lot of consideration.
Especially multiple sites, it gets extremely complex.
And then it's like, oh, I have an even number of nodes, I should have a witness. I don't have an even number of nodes, I shouldn't have a witness.
And if people would take things out to maintenance for a while, they'd have to reconfigure all of their quorum settings and stuff.
It got crazy. It got crazy. So what we've done in 2012 R2 is that we will now, what we call dynamic witness, we will automatically toggle the vote of the witness depending on whether we need it or not, or whether it's the best configuration. So take this example. So you deploy your 16-node cluster, and you have your 16-node cluster, and it has a witness. Actually, let's say you have a 16-node cluster, you want a witness, right? So you want to have a tiebreaker and decision maker. So you want a witness. But if you power down a node, dynamic quorum is going to kick in, and you're going to go from 16 nodes to 15 nodes. Now you have an odd number of nodes. Well, now you probably don't want a witness. So we will automatically say, hey, you got an odd number of nodes. Let's toggle the vote, and then let's keep. So now we're up to. That'll bring us up to. That'll be a decision maker. So we'll toggle on and off depending on whether there's an odd or an even number of nodes in the cluster.
So let me get this right. Basically, our goal is to always have an odd number of votes, right? So that if we have any partition, there's always odd.
Yep.
And so as these nodes go up and down in the cluster, we basically turn on and off this witness to always ensure we have an odd number.
Yep.
Nice, nice.
And so here's, if you don't understand anything I just said, which is okay because that's pretty hardcore, but if you don't understand anything I just said, the key point here is that the message in 2012 R2 is always configure a witness. We'll figure out when the best time to use it is. And you don't have to worry about all these quorum modes and do I need a witness and don't I need a witness. It's just simple. You just always configure a witness. We'll figure out when the best time to use it is, and everything will be dynamically moving and shifting and changing and adjusting and being smart as we go.
Right. Now, of course, a witness can be either a file share or it can be a disk. Now, we actually had another question that just came up asking about storage tiering. Is it possible to use storage spaces as part of storage tiering? This customer already has, their existing storage in place. Can they use this existing storage?
With spaces, you're saying, or with?
Yeah, with spaces.
Okay, so so if you have an existing, so spaces is kind of going back is only designed to run on top of. We don't want to run a controller on top of a storage controller on top of a storage controller. So Spaces is designed to work with JBODs, and we don't actually support running Spaces on top of anything which has any sort of RAID logic in it. So we don't support running Spaces on top of a RAID controller, on top of a SAN, be it Fiber Channel or iSCSI. We don't want to run Spaces on top of that. And tiering is supported within Spaces, is a feature of Spaces, so it's not a feature outside Spaces, it's a feature within Spaces.
Okay. Now moving on slightly, let's talk a little bit about Hyper-V. I've heard from some of the other cluster PMs that we're now treating Hyper-V clusters a little differently in how they get configured, how they run. I mean, in 2012 RTM, we made a new set of additions in our validation report, specifically tested for Hyper-V. But what are kind of the new things that we've added in this R2 release?
So we've actually done some optimizations around a Hyper-V cluster and how we kind of tune things under the covers and how they work. So we've kind of made two changes there. So one of the things we've changed is how we do our heartbeating between the nodes in the cluster. So by default, cluster nodes are sending heartbeats between the nodes in the cluster once a second.
And a heartbeat is basically a health check, right?
Yeah, it's like,
are you there?
Are you there? And then you say, yes, I'm there. And then we say, it's an actual handshake. It's not like a ping. It's actually a full handshake between our kernel mode driver and NetFT. And so we're doing these handshakes between the nodes in the cluster saying, are you there? Actually, I did a whole hour on like this topic. I could rabble for a whole hour. So check out my session for sure if you want the whole nuts and bolts here. But we're doing these heartbeating between the nodes once a second. And if a node isn't available for up to 5 seconds, then we actually deem the node down. We shoot it, we kick it out of cluster membership, we figure out everything that was running there, all those virtual machines, and then we cold start them somewhere else.
Do some recovery actions.
And we do recovery actions to say, hey, that was unhealthy, let's get going. And so what we've done is that's actually our default configuration is pretty darn aggressive. And we kind of do that in the holy grail of high availability, like making sure that when things go wrong, we detect it as fast as possible and we recover. But with a Hyper-V deployment, and that works great for customers who are deploying Tier 1 SQL, that's what they want. A scale-out file server, that's what you want. You want to have fast detection because it's zero downtime. But with Hyper-V, what is the definition of downtime? And traditionally that is when can a client, a user out there, no longer connect to the application running inside the virtual machine? And what is that? And that's usually defined by TCP, right? They're using a TCP-based application, and what is the transparency that a TCP reconnect can provide, a TCP reconnect window. So let's take a scenario. So say like you have a 7-second network failure, right? Let's say you have a brownout, you have an unreliable network. You have a poor network, I know you do, so. And you have brownouts, right? That you're having these brownouts where you can't connect for a while, but then network connectivity comes back up. If you had a 7-second brownout, so this transient network failure, TCP would make that seamless, right? That your application the session would never drop, it would reconnect, and from a client perspective, that app is up and running and solid. From a clustering perspective, right, we're going to go, oh, that node is down.
There's a problem.
There's something bad going on. We're going to shoot it, and then we're going to recover. The problem there is clustering actually caused downtime opposed to saving your downtime. Does that make sense? Because it was a 7-second network hiccup, but we detect that we can only sustain a 5-second failure, and then we recovered. So the answer is that if your definition of downtime is TCP, then we should probably be a little more relaxed. And that made sense with Hyper-V. So with Hyper-V, we have now increased the thresholds to 10 seconds by default. So when you create a VM on a cluster, we're going to crank up our thresholds to 10. For a user, you could even go as high as 20. I probably wouldn't go over 20 because if you're over 20, then you're exceeding the TCP reconnect window-ish. It's kind of a little rough, but then it's not really gaining anything. So that's one of the big improvements. And then we also did changes in the way we update the nodes in the cluster. So with a Hyper-V system, so today in a cluster, everything is a synchronous distributed system. So if we update a node, we have to acknowledge across all nodes. And then we update another node and we
So what do you mean by update? Is that like we change a property, we bring a resource online?
All of that.
So any kind of state membership change that happens on any node, we push out the change to all the other nodes, is what you're saying. So we have this consistent view.
You create a resource, right? We have to put that in the database and push it around the other nodes. Okay. If you fail over a resource, what is failover? So basically you take a resource, you offline it, we have to update all the nodes offline. Then we transition ownership, update all the nodes. Then we online on the other side, update all the nodes. And we have to get an ACK from all the nodes in the cluster.
So as we kind of scale up to 64 nodes, we're saying we got to get 63 ACKs back.
Right.
Okay.
And if you have a node, which is maybe you put one node off in a disaster recovery site, the cluster can only move as fast as the slowest node. Because we got to get
So that ACK's got to go to the secondary site and the request, and then the ACK comes back.
Yep. The ACK has got to go all the way to the site and come back before we can move forward. So one of the other changes that we've made is that if you create a virtual machine, we will actually then switch the mode in which the cluster does communication to kind of an asynchronous mode. But what we do is we will actually move to a quorum. So as soon as we get an acknowledgement from a quorum of nodes in the cluster, we're going to move forward.
Nice. Now, on the topic of this network resiliency, one of the challenges that I heard customers having is, if a VM was unhealthy and needed to be moved to another node, we didn't really do any checking to make sure that the network was still healthy on that other node. What kind of improvements have we made here around kind of this network health detection as we're moving our VMs?
Yeah, that was probably like the last remaining, I'll say, like kind of hole in our HA story. So if you have a file cluster or a SQL cluster, and if you walk up and you yank the network cable out of the front of the server, SQL would detect it, file server would detect it, and we would fail over from one node to the other one. However, with a Hyper-V cluster, right? If you walked up and you're wandering through the server room and you trip over the cables, what's going to happen is that those VMs are going to stay running on that node. They're not going to fail over. So the VMs are happily running, but there's no network connectivity. Nobody can get to it. There's no connectivity. Effectively, that VM is down. So what we've added in 2012 R2 is that there's component level health detection. So we will actually take the media sense, bubble it up through the host partition, through the virtual switch up to the VM, and then take recovery action. It's actually configurable. You want me to show it to you real quick?
Yeah, sure.
All right, so let's go to my cluster here. And if I look at my virtual machine, I can go right into the same settings. And let's see.
And again, this is pulling up the Hyper-V settings, right?
Yep, so I'm just pulling up the Hyper-V settings. And if I go in here, and so here's my network interface for my virtual machine. I can go to advanced settings, and you're going to see this new checkbox that says protected network. So what this means with a protected network is this is a clustering is health detecting and watching this network. So let's say you had 3 or 4 networks which were connected to this virtual machine. Maybe one's a backup network, not that important. So you can actually go in and uncheck that, which means that if I lose network connectivity on that network, don't fail over. But you have granular control that you can say, which ones do I want to be health detecting and which ones I don't for your virtual machines.
Now, would you recommend this as a best practice to enable this?
It's actually enabled by default. So
Great.
For every network that gets created and for all virtual machines, it will be enabled and will be health detecting. So what we're saying is all networks by default are important, and then we're leaving it up to you to go tell me what's not important.
Great. Now, another challenge that I've seen with the last release is about kind of balancing our CSV coordinators. So, if you had nodes that gradually failed, those disks, the CSV coordinator would gradually get pushed onto one node or a small subset of nodes. So you'd have most of the traffic for that CSV disk just running on a couple nodes. That's really not optimal, but I heard you've made some improvements to address that as well.
Yeah, so we wanted to get smarter. So let's say, for example, you have a 10-node cluster and you've created 10 LUNs. So CSV is cluster shared volumes, which is a clustered file system. So with any clustered file system, you have to do orchestration of metadata. And what's unique about CSV is we do all of that server side, and that gives us a lot of parallelization that we can actually have better performance for virtual machines. That's why we don't have big, long white papers about guidance about how many VMs to put on a CSV volume, because we don't have any of the restrictions that maybe some of the other guys do. But okay, so everything works in parallel. So, and actually on a per LUN basis, you can do a coordinator or an orchestrator. We call it the coordinator node. And you probably want to spread those out. And so it could be in a situation where maybe you do backups or through failures. You could end up with all 10 disks on one node, and on one node doing all the coordination orchestration for all the nodes for all volumes. And we say, hey, we could do better than that. Let's try to spread that out across the cluster. So what we'll do is that as nodes join the cluster, so if you add a new node to the cluster, if a node gets rebooted and comes back up and says, hey, here's a new available node, let's seamlessly transition a CSV volume over to that node and just try to spread things out and be smarter about how we do things.
Very nice. Now, let's talk a little bit about extending from our primary data center to our secondary data center by looking at the Hyper-V replica. So Hyper-V replica, really popular feature. It's kind of our inbox-free disaster recovery solution for our VMs. What's been improved with this in 2012 R2?
Sure. So Hyper-V replica actually does point-in-time replication. So what it does is you have a virtual machine or a VHD, and then you take that VHD and you're copying it off to a remote location for disaster recovery. So Hyper-V replica does point-in-time replication every 5 minutes, where it's basically every 5 minutes taking a VHDX and pushing it off to a remote site, and it gives you a crash-consistent copy. You can also configure app-consistent copies, and you probably do that at a less frequent interval, maybe every couple hours.
But you said every 5 minutes, though.
Every 5 minutes.
Okay.
So here's the thing: is that in the event of for a planned failover, so if you let's say I'll call this a disaster avoidance. So for example, when we had some amazing stories about when the hurricane was hitting on the East Coast.
Hurricane Sandy, right?
Hurricane Sandy. What was happening is that there were many companies who recognized the hurricane's coming, the hurricane warnings, and they did a disaster avoidance. And basically what that means is that they proactively failed over to the disaster recovery site and said, oh, we got a hurricane coming, Sandy's coming, let's proactively fail over to another site. And they did that, and they failed over, and that's zero downtime. So I shouldn't say zero time, zero data loss. So they did a transition across the other, and there was zero data loss. So Hyper-V Replica delivers zero data loss for disaster avoidance scenarios. For disaster recovery, in the sense of an unplanned downtime, a tornado, for example, there can be up to 5 minutes of data loss. Because we're replicating every 5 minutes, there can be up to 5 minutes of data loss. So we had some customers come to us and say, that's too much.
Yeah.
Like I'm losing too much data. And we had other customers who said, no, that's too often, right? You're pumping
killing
too much
my
data.
networks,
You're
right?
killing my network, that's too much. So it's like, you can't keep everybody happy, right? Some too fast, too slow. So we'll give you both, right? So now with Hyper-V Replica, you can actually do replication every 30 seconds. You still get every 5 minutes, and so you can do 15 minutes. So you can get all the way down to 30 seconds of potential data loss in the event of an unplanned failure.
Nice. Now, what happens if you want to go and you have multiple data centers? Is there any way to do replication on replication?
Yeah, so another one of the things is we really want to go from supporting, so many customers will have many tiers of disaster recovery. So they'll have what we call a metro recovery. Metro recovery might be across the river, a couple miles.
Metro meaning like in a small city kind of thing.
Yeah, like New York to New
So you lose
Jersey.
a block of power, you go to the other data center.
Yeah, a block or a power grid. New York to New Jersey is a nice example. So maybe you're going across the river, so you're going from New York to New Jersey, and you're doing failover across that. And you might want to have that replication time be very aggressive. You got fat pipes between the two, high bandwidth, and maybe you want to do replication every 30 seconds. But you also want to have another replica for geo recovery. So we got metro scenario, we have geo scenario, where maybe you have the third replica be in LA. So you got New York to New Jersey, and then New Jersey to LA. And you might want to have a different replication time with that. So we support that now. So you can do 30 seconds for metro, maybe you do, and then maybe from off to New Jersey, and then from New Jersey, maybe you're going to go every 15 minutes off across geo.
Nice. Now, one question that I've heard a lot of customers ask is, with the Hyper-V Replica, does this change our multi-site clustering model? Traditional multi-site clustering, we'd have a single cluster that spanned both sites. Mm-hmm. In Hyper-V Replica, we have when it's on a cluster, we have what's called the Hyper-V Replica broker, which is, kind of a highly available replica engine, but it doesn't replicate within a cluster. So how exactly has this changed our replication model? Or our multi-site cluster model here?
Yeah, if you look at our disaster recovery story, there's actually many ways to do things, is the first part of this, right? Is that
a lot of choices, that's a good
thing. There's many
thing.
choices for disaster recovery. I mean, in the sense of, for disaster recovery, you could be doing virtual machines and Hyper-V Replica, and that could deliver up to 30, you could have up to 30 seconds of data loss. Now, if you're a stock trader in Wall Street, that's probably not acceptable.
Unacceptable.
But you couldn't accept losing 30 seconds of downtime. So we also fully support, so every major storage vendor supports hardware-based replication. So whether it be EMC or NetApp or HP, they all support hardware-based replication. And they fully integrate into failover clustering to allow to do disaster recovery with their synchronous replication hardware solutions. They have asynchronous as well, to provide you zero data loss guarantees. So Hyper-V Replica is, great for tier 2, and if you have a tier 1 with really strong SLA requirements, zero data loss requirements, you may be looking at things like hardware-based replication for these storage vendors, and we support that. Mm-hmm. And then another, just to throw another ingredient to the mix to think about here is applications, right? SQL has SQL always on with availability groups, so you can actually do disaster recovery at the application layer and be doing replication of databases from effectively Metro or Geo, and they support replicating the databases as well. So it depends on your application, right? You may be doing, maybe you're going to take all your file servers and throw them into a virtual machine, because if an administrative assistant loses some PowerPoint, or marketing guys, where are they? If the marketing guys lose some PowerPoints, who cares about those guys, right? So maybe that's perfect workload that you put inside of a virtual machine for Hyper-V. But with your tier 1 SQL, which is the backend for your online, e-commerce site, you can't afford that. So then maybe you're doing SQL always on at the application layer. Does that make sense? And so there may be different scenarios that you can use different solutions. But going back to your original question, which I didn't even answer yet.
Hyper-V Replica broker, yep.
Replica broker, right. So there's actually different models. So if you're going to do Hyper-V Replica, you're actually doing replica between a cluster in one location to a cluster in another location. And but if you're doing a replication with a storage vendor underneath doing synchronous replication, you actually do a single cluster and a stretch cluster across sites. And the reason you do that is because then clustering is the orchestrator, and we're actually controlling failing over the stores from one site to the other one. Now with Hyper-V Replica, it's always manual failover. So that's why you have 2 clusters, and it's manual failover. So that means that in a disaster, you have to go hit the peripheral big red button, and you say failover across sites.
Now, talking about this failover, I heard one of the features that was announced this week is called the Windows Azure Hyper-V Recovery Manager.
Okay.
Can you talk a little bit about that?
Sure. So that is a service which runs in. So let's take a step back. With Hyper-V Replica, as you know it in 2012 today, it is great for failing over a virtual machine from one site to another one. But what if you need to fail over your entire data center, right? Hurricane Sandy's coming. You need to fail over hundreds of virtual machines across from one site to another one. That is an orchestrator which will enable you to really do orchestration and site failover, not just VM failover, but site failover of all the virtual machines integrated in the Hyper-V Manager, and really make it a single pane of management experience to get to failover.
Okay, great.
So it's all about management and single pane of glass and an orchestrator and making it simple.
Well, I think by now, we've kind of convinced people that they really want to go and upgrade to the newest versions, but where can they go and learn more information about all of this?
So we have a cluster blog, so all these new features, we just came out on, like in the last couple days, so we're going to be going home next week, we're going to start writing blogs, and we're going to start getting it up on our blog site, so that's a great place. You can go to the Virtual Academy, there's great things you can learn there, information that's being posted there as well.
Great. And quickly, those URLs are blogs.msdn.com/clustering and www.microsoftvirtualacademy.com. Well, with that, thank you so much for joining me, Eldon. Again, we have a ton of great cluster sessions throughout the week, so view the videos from the past, view the upcoming videos later today, and thanks again.
Thank you.